In this video, we're going to prove that when you differentiate the inverse cosech of x, we get to this function here, using these two rules. As always with these questions, whatever you're differentiating, we introduce that as a function y, and then we apply whatever we need to get rid of the inverse. So here we're going to apply cosech to both sides. What you then want to do is differentiate both sides with respect to x. So when you differentiate the right hand side with respect to x, that's just 1. When you differentiate cosech of y, that'll get you minus cos of y, cosech y, but then you have to multiply it under dy dx, because this is in terms of y, and we're differentiating with respect to x. Now that you made dy dx the subject of the equation, we need to write everything here in terms of x somehow, because that's what our final answer is, in terms of x. Now the cosech of y, we can just replace that with x, because we before formed the expression that x is just equal to the cosech of y. Replacing cos of y is a bit more difficult. You actually want to use this identity here. So let's actually write this in terms of x. I think it'll help us for the sake of this question. But you want to make cos of y the subject of this equation and replace cosech of y with x. When you make cos squared y the subject of this equation, you can then make cos of y